So today's kind of a bit of review mixed in with another way to do something that we have done in the past. Now this says find dy of dx for y equals x squared, square root x minus squared, evaluate at 3, 9 root 5. So what are they asking for? What does y prime give me at that point? The slope at x equals 3. Okay? So let's use the product rule. I'm just going to rewrite it. Y equals x squared times x squared minus 4 to the 1/2. So we'll go y prime is the first times the derivative of the second, which is 1/2 x squared minus 4 times 2x plus derivative of the first times the second, x squared minus 4 to the 1/2. Yeah. Sorry, yeah, right, negative 1/2. Okay. In the first part, this x, oops, won't cancel. We got a cube that's still there. So we're going to have y prime equals, we got the 2's will cancel. That's what I was thinking. And I got x cubed times x squared minus 4 to the negative 1/2 plus 2x times x squared minus 4 to the 1/2. Okay, I can factor out an x on both of them, and I can factor out an x squared minus 4 to the negative 1/2. So y prime, I'm going to take out an x, add an x squared minus 4 to the negative 1/2, which give me x squared in the first term, plus 2, because I took out that x, and then just x squared minus 4 to the 1. So y prime would equal x times 3x squared minus 8 all over x squared minus 4. Let's even square root that. I just multiplied this 2 in here to get 2x squared minus 8, and I had an x squared, so that's 3x squared minus 8. And I brought that negative exponent down. Now if I want to know the slope at that point, I just put 3 in. Okay, so slope equals m equals, so I'll put a 3 in there. I'm getting my 3 from here. 3 times 3 times 3 squared minus 8 all over 3 squared minus 4. X squared minus 8. 3 times 3x squared minus 8. Oh, you're still up there. You're still up here. Okay, I get you. Yeah, that's my 3x squared. I was looking at my slope form. I'm like, what? I don't get what you mean. And this is, I get 57 over root 5. And to just decimal, I will get 25.49 is the slope to the nearest hundredth. Okay, so those you've done before, doesn't hurt to do a little bit of review, but hey, we are doing the log unit. So there's another way to do it using logs, and I think it's kind of arguable which one's faster for this question, but I'm going to show you one question where it is a ton of work to do the product rule, but not bad when you use the logarithmic differentiation or using lns. Okay, so if we have, let's just write it again, y equals x squared times x squared minus 4 to the half. So what I'm going to do is I'm going to log e both sides, or just ln both sides. So I got ln y equals ln x squared times x squared minus 4 to the half. And that's all one thing, right? What makes using logs nice is because I can use my product rule, and I can split up that stuff on the right. So that would be ln x squared plus ln x squared minus 4 to the half. And even to save a step, I can put the half down here right now. And once you have it split up as much as you can, then you can just differentiate. I'm just going to write this here just as so d over dx of ln u equals 1 over u du over dx, right? So ln y would be 1 over y times y prime, because that's implicit. You're doing it to x, so that would be dy over dx, equals 1 over x squared times the derivative of that would be or just a minute, sorry, 1 over u. Oh, what am I thinking? I should have got my 2 down here for this one as well. Yeah, get rid of exponents, or else this this one, then you've got to do your chain rule, and it's not, you probably get the same thing anyway quick enough. But so I did just 2 times 1 over x, where you would have had 1 over x squared times 2x, and then the x's would have canceled. You would have got the same thing, right? Plus the 1/2 stays out front, and then it's 1 over x squared minus 4 times 2x. Now, if I want to get y prime by itself, I'll put y prime there equals, now see the 1 over y? I'll multiply this side, and that's just 2 over x plus these two cancel, x over x squared minus 4. Now, they were nice to give us both x and y, and now I can plug x, y in. Or you could have just taken your x value and put it into the very first y formula and got the got y. But when you plug in, so we're plugging in 3 and 9 root 5. Right, if we put it into here, we get m to equal 25.49. Okay, this is my x and this is my y. Now, I guess it's kind of a toss-up on this one, which one would be more work, but they both work, even though they have entirely different looking formulas. But where it really comes in handy is for this question right here. So when you have 3 things multiplied together, okay, to do the product law, you have to do, so d of dx of, like say I have u times v times w. If you have to do the derivative of 3 things multiplying, you have to do the derivative of the first times vw plus the first times the derivative of the second times w plus uv times the derivative of the last. And that's a lot of work. Yep. So a derivative of the first times the second and third. The first times the derivative of the second times the third. And the last one is first and second times the derivative of the third. So you're just taking the derivative of one as you keep moving. And it is a big question, right? It would take most of this page. Now, if you are, and then the simplification at the end is even less fun. But if you take the log of both sides, or ln of both sides, so let's use logarithmic. Okay, so that would be ln y equals, and I'm just going to split this right up, ln x plus ln 3x plus 1 to the half plus ln x minus 5 to the half. And then we can get in the habit of this step, putting my half here and my half here. Yep. No, good. Okay, so this would be 1 over y prime equals 1 over x plus 1 half times 1 over 3x plus 1. We've got to do the derivative of the bottom, so we're going to multiply by 3 plus the 1 half, and then 1 over x minus 5 times 1. So even going through this part, it's not as bad as, well, I mean, if I would have done the other one, you would have seen how much time it takes, but I thought I'd spare you. So y prime would equal y times 1 over x plus 3 over 2 times 3x plus 1 plus 1 over 2 times x minus 5. So if they don't give you the y value, but they give you the x, you can just plug the x into your y formula. But to be very, very specific, we know what y is, and that's x times 3x plus 1 to the half x minus. So we can actually sub that in. So that would be x times root 3x plus 1 times root x minus 5 all times 1 over x plus 3 over 2 times 3x plus 1 plus 1 over 2 times x minus 5. So I just took my y and put in y. Now if they give you the x, you can just plug that into the top one and get a number and then multiply it in with everything else. Okay, so now we are going to just do review of the last unit. Okay, it says find the equation of the tangent to y equals x ln x with the slope. It has a slope of 2. Okay, so they've already given me my slope. What I need to find for, well, y minus y1 equals m times x minus x1, right? That's the equation of a line. I already know m, but I don't know x. And because I don't know x, I don't know y. So I'm missing two things. But if I find the derivative of my equation, I make that derivative equal to 2, I can find x. Once I find x, I can put it back into the formula and find y. Okay, so let's do the derivative. So we have y prime is equal to the first times the derivative of the second would be 1 over x, plus derivative of the first is 1 times the second ln x. Those x's cancel, so I have y prime equals 1 plus ln x. Now I know the slope is 2, so 2 equals 1 plus ln x. I subtract 1 to both sides. I will have 1 equals ln x. Now what do you think x is? E, right? Because ln e. So now you could change that to exponential if you really, but you should just be able to see e equals x. Because ln e is the same thing as log e to the e, which equals 1, right? Okay, so now find y. So we have, my original is y equals x ln x, y equals e ln e. We already know what ln e equals. It's 1. So we have 1 times ln e, so y equals e. So we got everything we need. So now it's y minus e equals 2 times x minus e. So y minus e equals 2x minus 2e. Why don't I get everything on the right? So 0 would equal 2x minus y. I'm going to plus e to both sides, so that's minus e. Okay, so this one is a lot easier than the other ones you've been doing in the last unit. Okay, find the equation of the line tangent to this curve at point x equals 0. So this one I know the x, but I do not know the slope. I also know the y, right? I can find the y quite easily, but let's find the slope. So we can do the equation. So we got y prime equals, now the derivative of e to the negative x is e to the negative x times the derivative of the exponent, which is negative 1, plus e to the 2x times the derivative of the exponent, which is 2. Did I do something wrong, Pavel? Did I do something wrong? Okay. Okay, so this would be y prime equals negative e to the negative x plus 2e to the 2x. So slope when x equals 0, y equal negative e to the negative 0 plus 2e to the 2 times 0. So negative e to the 0 equals negative 1 because of the negative sign, and then I've got plus 2 times 1. So m equals 1. Okay, I need to find y yet for my equation, and that is just e to the 0 plus e to the 0, y equals 1 plus 1, y equals 2. So I've got 0.02, and I got a slope of 1. I don't know if it gets much easier than that. So y minus 2 equals 1 times x minus 0. Y minus 2 equals 1x. 0 equals 1x minus y plus 2. I saved the best for last. You wait till you look at the next page. More fun. Yeah. All that first derivative, second derivative, interval tests. Okay. Intervals of increase, decrease, max and min, concavity, and point of inflection for each of the following. Okay? First one, let's do intervals of increase and decrease. Okay? Well, how are we going to know that? By doing our first derivative. Okay, so let's do 1. Increase, decrease. So this is going to be y prime equals e to the negative x squared times the derivative of negative x squared. So that is negative 2x. So y prime equals negative 2x e to the negative x squared. Okay, so we got a CV where what would make this equal 0 when x equals 0. Okay, and it doesn't apply to this one. Okay, nothing will ever make, no exponent ever makes anything equal 0, but this obviously would. Now, let's do this. We got 0 here, and we want to pick some test values on both sides. So if you, I don't know, say pick negative 1, right, we would get, so we get a negative is out front there, then a negative 1, and that will also, like, no matter what you put in x up top, it'll still be a positive number. Okay? Nothing here can make this negative, right? So that will still be a positive. So if I got a negative times a negative times a positive, I got a positive right here. Okay, so let's try 1. We got the negative in front of the 2, and then times, that's a positive, right? X is 1, and then this will be a positive, so this will be a negative. Okay, so we got increase over this interval, and we have decrease over this interval. So increasing, negative infinity, comma, 0, decreasing, 0, comma, infinity. Okay, we have a max at f of 0. If we put 0 into the original equation, we'd have e to the 0, which would equal 1. Okay, so because max was number 2. So we found, here's my increase decrease for number 1. Here's my max they wanted for number 2. Concavity, for concavity, I need to do second derivative. Okay, well, I'm going to write down my first derivative, 2x e to the negative x squared. Oh, This is going to be fun. Okay, so we're going to use the product law. So y double prime equals, so I'm going to do the derivative of x, so that's just going to be negative 2, or negative 2x, just negative 2 times e x to the 2. So I did the derivative the first times second. Now it's the first, negative 2x times the derivative of the second, which is e to the negative x squared times negative 2x. Okay, let's just kind of clean things up. Can't do much with this. So that's just negative 2e to the negative x squared. Plus, here I've got a 2 times negative 2 is 4. X times x is x squared. E negative x squared. Yep. Why did I do what twice? Oh, this is the product law, right? It's derivative of this times this. So I had to do the product law. Okay, I'll write that down. Yep, I'm still cleaning here. So I can take out a y double prime. I can take out a negative 2 e to the negative x squared, which gives me 1 minus 2x squared. Now this is a valuable step for finding CVs, because all I really need to do, now you can bring that down below if you wanted to, right? That e to the negative x squared, but nothing will make this equal 0. Okay, so we don't have to worry about this. But here is where we can find a critical value. So I'll say can't equal 0. But this we can. 1 minus 2x squared equals 0. I'll bring 1 equals 2x squared. You can divide by 2. 1/2 equals x squared. Plus or minus 1/2 equals x. Oops. Square root 1/2 equals x. Or plus or minus 1 over root 2 equals x. Okay, whatever you... So let's test for critical values. I have 1 over negative 1 over root 2, 1 over root 2. Okay, so I used negative 10 here. Okay, now if you put negative 10 into this, now first of all, we're putting it into here, right? So we've got our negative that's out front, right, in that first part that I've circled, and then in brackets, that'll give us a negative, so we will have a positive here. If I put 0 in, I would get a negative still in the front, that's staying there, and then 1 minus 0 is positive, so that's going to give me a negative there. And I tested like 10 over here, and I would get the same thing as when I put negative 10 in there because it's squared. So that's negative, negative. And that's going to be positive. So happy, sad, happy. Okay, so we are concave up. Negative infinity, comma, negative 1 over root 2, union 1 over root 2, comma, infinity. And I am concave down, negative 1 over root 2, comma, 1 over root 2. Okay, last thing, ask for points of inflection. So inflection points. So the inflection points, I'd have to put in f of negative 1/2, because it goes from concave up to or 1 over root 2, I should say, negative 1 over root 2. And that goes into the original, okay? So that's e to the negative x squared, okay? X squared is 1 over root 2, so that's going to give me the 1/2, e to the negative half, which equals 1 over root e. And if you put in f of 1 over root 2, that would be e, there's the negative, and then I'm doing the 1 over root 2 squared, would be 1/2, so that also equals 1 over root e. Okay, one more. Now, the reason I've got to do b as well, because b has a little bit of a caveat in it. It's that by looking at it, number one, any x could work. You see with, or a I should say, with b, what do we know about that x? The x has to be greater than 0. So we want to remember this domain, because domain does not increase as you go through a question. The restriction must stay there. And it actually helps you. Now, if you were going to do your number lines and stuff like that, you would find that you're getting undefined there all the time. So you wouldn't be totally lost, but this just kind of, okay, one more time. I think it's the last time of the year that we have to do this. So, okay, let's do the, oh, and the final. Last time that I have to teach it to you. Last time you have to listen to me. Okay, the chain rule, bring out the 2, ln x, and then the derivative of ln x is 1 over x. So this equals 2 ln x over x. Okay, so critical values. We have when, what would make all the top equal 0? If ln x equaled 0, so when x equals, so when ln x equals 0, therefore when x equals 1, and what would make the bottom undefined? X equals 0. And that's kind of would be an asymptote, right? We would be thinking at that point. And it's kind of an asymptote, not kind of, it was an asymptote anyway, because y has to be greater than 0. Okay? So if we draw our line, we have 0. We can even go like this, right, to show that I'm not even going over there. And then 1. Okay, so I used like a half. And if you put a half in, because ln of a fraction always gives you a negative, so that would be negative over positive, right? If I used a half, I should put half down there. So that gives me a negative. And if you put in anything greater than 1, like 2, so 2 ln 2 would be a positive over a positive, so I got a positive there. So we're going down, and then we're going up. And this one we're even going to try and draw the graph. Okay, so we have, we're increasing. Let's do decreasing first. We'll go left to right. Decreasing, not negative infinity, but 0 to 1. And we're increasing 1 to infinity. Okay, so we got a min at f of 1. Remember, put that in the original. So ln of 1 is 0. 0 squared is 0. So we got a min at 1, comma 0. Okay, so now we've got to do our concavity. Okay, I want to write down my, oh no. Okay, y prime equals 2 ln x over x. So I'm going to use the quotient law, or sorry, yeah, the quotient law. I know nobody likes it, but it's good to practice it. So low times the derivative of the high, which is 2 times 1 over x. Well, you could even bring the x to be a negative 1, use the product law, and then do that. Yep. And then minus 2 ln x times the derivative of the bottom, or the low, is over times 1 all over x squared. In the first one, the x's cancel. So y double prime equals 2 minus 2 ln x all over x squared. So I've got CVs. Oh, you know what helps make this even easier? If I take out a 2, 1 minus ln x over x squared. So I got CVs at 0, and when 1 minus ln x equals 0, so that is when ln x equals 1, and that's when x equals e. Okay, anyone remember what e is? 2.7 something. So that's always good for when you're doing your test. Okay, so we don't have to worry about it on this side of 0. E is over here, and that's just 2.72. I'm putting that down so it makes sense how I picked my test values. So I'm going to use 1. So if I put in 1 there, I get 2 times 1 minus 0 up top. So I get a positive over 1 squared is positive. So I get a positive there. And if I put in 10, 1 minus ln 10, okay, ln 10 is bigger than, so I'm going to get a negative up top. And on the bottom, I get a positive, so that's negative. Okay, happy, sad. So I'm concave up would be 0 to e, concave down, e to 10. E to infinity, yeah, whatever that one. I like my 10. Okay, now just have to find inflection point. So if we put in e to our original equation, so f at e, so that would be ln e squared. That is 1 squared, which equals 1. So we have e comma 1 is my inflection point. Now, we didn't test a on both sides of our asymptote to see if it's going to positive, negative, infinity, but it does go to, I'll tell you, it goes to positive infinity as x approaches 0 from the right. Okay, so if I might just give you that information. So, and then we've got to go down to, at 1, I have a increase. It's going from decrease to increase at 1. 0. 1, 0 is my, that's where I'm changing from, I'm going down to up. Okay, I also have an inflection point at, okay, so this is 1. I have an inflection point at E, comma 1. So it'll be about there. So I change from concave up all the way here to concave down here. So as I approach 0 from the left, if I'm going to positive, going to infinity, so and I'm coming down here. I'll do this in black. So I would be coming down here. Okay, still concave down, or concave up, I mean. Then there's an inflection point here, and it's going like that. Look good? It's supposed to look like that. Yeah. So that's why I don't let you have graphing calculators, actually.